In the last few videos, we have discussed various operations that can be applied on array objects that are supported by Numpy. In this video, we will see the statistical operations that are supported by Numpy array objects. So basically, we will look at various operations like how to apply the mean, median, standard deviation, variance. So such kind of operations, how they can be applied on the Numpy array objects, we will look into them in detail in this video. In this video, we will look at various statistical operations on Numpy array objects. Numpy supports various methods to perform the following statistical operations like to find the minimum, maximum, mean, median, standard deviation, variance, average, then peak to peak values, and in addition you can also find the weighted average and the percentile operations. How to perform all these statistical operations using the Numpy array objects? So we will see with some examples. So Numpy supports various methods like min to find the minimum value, max to find the maximum value, mean method to find the mean value, median to find the median value, and std to find the standard deviation, var to find the variance, average to find the weighted average, ptp to find the peak to peak value for a range of values, average to find the weighted average, percentile which determines the nth percentile of data along a specified axis. So all these methods supports to perform various statistical operations on Numpy array objects. So these methods allows you to apply the operations along a specified axis. And if you consider any two-dimensional array object, when you pass the axis equal to 0, that indicates the operation is applied column wise. When the axis is set to 1, then the operation is applied row wise. So consider this two-dimensional array object which is of size 3 by 3. You can use the sum method to get the sum of the total elements in the array. When you do not provide any axis value, then the sum value computes the sum of the entire elements in the array object. To find the sum along with the axis, you need to provide the axis argument also. When the axis value is set to 0, then it finds the summation across the columns. If you observe 39, 39, 45, it indicates the summation over the columns. The first column sum is 39, the second column value sums up to 39, similarly the third column sums up to 45. That's how you can mention the operation has to be performed along which axis also in all these statistical operations. And similarly, if you would like to find the row wise summation, then you can set the axis value as 1. And to find the minimum value in the array, you can use the min method. So min or min, either of these methods you can use. So when you do not provide any axis value, then in the entire array object, whatever the minimum value is available, that value is returned. And when the axis is set to 0, then it finds the minimum value along each column. And similarly, in this column, what is the minimum value? So that is how it finds the minimum value along each column when the axis is set to 0. Similarly, when the axis is set to 1, then row wise, what is the minimum value? So those values are returned. And to find the maximum value, you can use the max method or the max method. So when there is no axis argument, then in the entire array object, what is the maximum value that is returned? In case of axis is set to 0, then the max value along with each column is returned. When the axis is set to 1, then row wise, what is the maximum value? Those values are returned. So now how to find the mean value? So to find the mean value in the array object, you can use the mean method when there is no axis object. So similar to the previous method, it returns the mean of the entire elements in the array object. When the axis is set to 0, so it's a column wise mean. When the axis is set to 1, then it returns the row wise mean. So that's how you can find the sum, min, max and the mean values. Similar to these values, you can find the standard deviation also in the array object. So you can use the std method to get the standard deviation of the entire set of elements in the array object, or you can find the column wise or the row wise standard deviation also by setting the axis argument. var is the method which supports finding the variance of the elements in the array object. So var method, without passing any axis argument, it computes the variance of all the elements in the array object. When axis is set to 1, then it finds a row wise variance. When axis is set to 0, then it finds a column wise variance. Numpy package supports average method which finds the weighted average of elements in the array object. So consider this one-dimensional array object. To make it more simple, I have considered the one-dimensional array object to illustrate the average method. When the weight values are not passed, then the average method works similar to the mean method. It simply returns the average value of the entire elements in the given array object. So here this array object contains 9 elements. So you need to pass 9 different weights as an argument to the average method to compute the weighted average of all the elements. What happens is while finding the average of these elements, these weights are considered. That is 0.5 into 1 plus 0.25 into 2, so on and so forth, by the total number of elements. That's how the weighted average can be computed using the average method. And you need to pass the weights as an argument to this average method to get the weighted average. So if you skip that argument, then it returns simply the mean of the entire elements. Now to find the percentile in the one-dimensional array object, you can use the percentile method. So the 10th percentile, the 30th percentile. So the second argument in the percentile method indicates what percentile value you want to retrieve. So the 10th percentile of the collection of elements of array A is 1. Similarly, the 30th percentile is 1.4. If you would like to find the percentile across any dimension, you can mention that with the help of the axis argument. You can pass the axis value as 0 or 1, or depending on the dimensions you have, you can increase the axis value also. And now consider this array object. So I am going to find the PTP value for the array object, which finds the peak to peak value. That is, what is the difference between the highest value and the lowest value within the array object. That can be identified using the PTP method. So you just need to pass the array object and along which axis you would like to find the PTP values. So that can be passed as a second argument. Consider the single dimensional array object. The peak to peak value in this array object is 2, because the highest value in this array object is 3 and the lowest value is 1. That's how the difference is 2. So that is what the value is returned. So now let's change this value to 30. So now let's find the PTP value. So you can see the PTP value is 29. The difference between the highest value and the largest value within the list of elements, that is known as the PTP value. So far in this lecture, we have discussed various statistical operations like how to find the sum of the elements, then mean, minimum value, maximum value, mean value of the elements, weighted average, then standard deviation, variance, and in addition we have also seen how to find the percentile of the collection of elements, the nth percentile of the elements. Then finally we have discussed how to find the peak to peak value within the range of elements. Now I hope you understand how to apply various statistical operations on the array objects in Numpy. Thank you for watching this video.